In this question, what's being asked is that the diagram shows two different compounds, 1 and 2, and they're asking what is the total number of structural isomers including compound 2, so including this one. So you have to count this one as well. That could be formed by adding a second methyl group to the ring of compound 1. So ring of compound 1, and you have to figure out the total number of structural isomers that are possible. So that part, the first part, is kind of easy. So all you have to do is you can add a methyl group over here, you can add a methyl group over here, or over here, or over here. So I think he was very specific that the methyl group has to be added. So it's either one of these. So you could have four different. In my opinion, you can have four different possible isomers, but there is no option for four. So that one is probably wrong. It's either 3 or 5. So let's see where else can we add a methyl group. So that was the tricky part. So you can definitely, this carbon is making, it's supposed to make 4 bonds, so you can add a methyl group over here. You can add it over here, over here, over here. Remember, there's a fourth option over here as well. The fifth option might be over here as well, that you could add a methyl group at this position as well. That would also be counted as a ring. You can't add a methyl group on this carbon atom because this carbon atom already is making 4 bonds. So there is no room left for adding another methyl group. So this carbon has no space. These carbons, they can still make bonds. You can replace some of the hydrogens and put a carbon on these carbon atoms. So that's 1, 2, 3, 4, and 5. So that's 5 possible ways in which methyl groups could be attached on this ring. And the next part was that the number of pi electrons, it says the number of pi electrons in each compound. In each compound, that's easy, that's and pi electrons. So that means you're supposed to count the number of electrons. So that's 1 pi bond, that's another pi bond, that's a total of 4 electrons. 1 pi bond has 2 electrons each. So 1 over here, 1 over here, that's also 4. So in my opinion, the answer is going to be option D.